Hello guys, in this video we'll be discussing about min-max algorithm. So what is min-max algorithm? Min-max algorithm is nothing but, so in a, for example, consider a game. So in a game we'll be having two opponents, right? One is you and other one is your opponent. So in each and every moment, for example, consider playing a chess. For each and every step you are doing, so the opponent what will be doing, you will be using an attack mode or a protect mode to protect from you, or you will be trying to attack you. So what is doing, so in our point of view is decreasing our outcomes. So in our point of view, in his point of view, he is increasing his outcomes or probability of winning. So that is what min-max algorithm says. So it is every step we have to take care. For example, if this is a camel, so you will be trying to find each and every possible way to move to the each and every corner of the chessboard, right? So we'll be trying to kill each and every node, each and every soldier or the queen or any of the piece on a chessboard when it comes to when it comes to the path of a camel. So that is what min-max algorithm. So we are trying to reduce the opponent's coins or opponent's power. So min-max algorithm is a recursive and backtracking algorithm. So I will let me write each and every step. So min-max, we'll be discussing a min-max algorithm. So what is min-max algorithm? It is a specialized search algorithm which returns an optimal sequence of moves for a player in zero-sum games. So I will discuss about game playing in next video, game playing part 2. So there I will explain the types of game playing. Okay, so don't worry, just right now in this min-max algorithm, just try to remember the names. Later I will be making a new video on that. Okay, so min-max algorithm nothing but it is a specialized search algorithm that returns optimal sequence of moves for a player in zero sum game. So we'll be trying to find the optimal sequence of moves for a player in a zero sum game. What is zero sum game? Zero sum game is nothing but the games we generally play. So one player will try to win the game, and another player will definitely lose the game. So that type of games comes under zero sum game. So there is a zero probability of one losing or one winning. So that winning it will be only to going to one particular person, and loss will be going to one particular person. So when you are trying to play in a multi squad games, so there might be a difference. So zero sum square is nothing but one should definitely win, another one should definitely fail. So min-max algorithm is nothing but so it's a specialized search algorithm which uses DFS as well as the backtracking and recursive methods, which represents optimal sequence of moves for player in zero sum schemes. So let me write another point, that is min-max algorithm, that is min-max MMA. Min-max algorithm is a recursive or backtracking algorithm which is used in decision making and game theory. So it is a recursive process for each and every step. For example, when you are moving it to a soldier, this is a soldier of yours, and this is a soldier of your opponent, and this is a soldier of your opponent. So what you will be doing, so you will be, so there is a no path, there is a only one possibility that we have to there are many possibilities that we have to stay here, or we have to kill this soldier. So what we will be doing to increase your chance of probability, so you will be trying to kill this particular node, and then later you will be staying here. Then later you can move your steps there. Or else if you want to stay here itself, then what will happen, this node, this particular soldier will be trying to kill your node. So we have to make each and every decision to be optimal to find a better solution. So we'll be using this MMA, that is min-max algorithm, in decision making as well as in game theory. So why we need to take these recursive steps? Because it provides an optimal boon for a player, assuming that opponent is also playing optimally. For example, when you are playing a chess game, so you will be thinking in your mind that whether I should place the coin here or whether I should place the coin here. So if I place the coin here, what will be happening, and later when I take the step back, what will be happening. So you will be trying to find the different ways of chances to get the required output. So it provides an optimal move for the player, assuming that opponent is also playing optimally. So why it is playing optimally? Because in your point of view, you will be trying to increase the chance of winning, but in the case of your opponent, you will be trying to get the win, right? So that's why you will be playing optimally to get the optimal solution, that is whether to lose or whether to win the game. So what min-max algorithm is mostly seen in chess, checkers, tic-tac-toe. These are some of the examples. So mostly seen examples are chess, checkers, and tic-tac-toe, tic-tac-toe, etc. So there are many other examples, but basically we will be doing it these three only. So in chess is a very So chess is the best example for min-max algorithm. For each and every step, when you are putting on your paw, so you'll be having a different possible paths, and you'll be having a different solutions, whether to move your coin or whether to take another coin in place of that. So that's all in chess. So in this algorithm, coming to the min-max algorithm, so in this algorithm they will be having a two players, that is one is the minimum and one is the maximum, that is min and max. So where min will try to minimize the solution in opponent's points of view, where max will maximize the solution in our point of view. So that is what they are doing. So in this algorithm, two players play the game. One is max, another there is min. So what we'll be doing, so they are so min and max are opponent of each other. So min will try to select the minimum value, and what does max do? Max will select the maximum value. Select the maximum value, right? So why we need to take min and max only? Because it is a probability of winning or loss, so we have taken min max, or you can take another variables. So it is just a numerator. So in max we'll try to maximize the value, in another it will minimize the value. So the range will be, for the max it is so minus infinity, and for the min it is infinity. So why we need to take minus infinity? Because what we need to find the maximum value. So when we compare maximum value to the minus infinity, which one will be maximum? The maximum values will be maximum. So that's why we'll be taking what is minimum value. So minimum value, when you try to compare with the positive infinity, so the less value will be the minimum, right? So that's why we have taken these two. So this will be taken in the worst values, and this will be considered in the initial or that scale in the scale values. So let us move to the, so I think hope you understand the concept of min-max algorithm. So min-max algorithm is nothing but we'll be trying to increase the chance of winning for a particular person or the opponent person. So that is what min-max algorithm it is. So let us move to the properties of min-max. So what are the properties of min-max? So hope you understand what are the properties from the theory we have discussed. So each and every step will be having a different possible steps. So it has to reach each and every step to check whether it has an optimal solution or not, or whether it has a better solution or not. So from the theoretically we can say that min-max algorithm is a complete it is a complete algorithm and it is an optimal because two players will be playing optimally. And for coming to the time complexity, for every paw we have to take we have to take different branches, right? So the time complex will be more, and the space complexity, coming to the space complexity, what we'll be doing, so in space complexity also it will be more enough. So this min-max algorithm drawback is that because for any huge cases like chess or TikTok, chicks and Chinese checkers, so there will be a huge branching factor, so we can't implement min-max algorithm for each and every game. So let me write properties, and later I will be writing the limitations. So what are the properties? I said it is one is complete. Why it is complete? Because it will be definitely find a solution if there exists. So it will definitely find a solution if and if there exists. If exists only, it will be finding a solution. If not, what will be doing, it will be going on continuing with this process. So second one, what is the second property I have told? It is an optimal because each player will be playing optimally to get win or loss. So MMA, so that is min max algorithm is optimal. Why? Because both player both players plays optimally, so they will be playing optimally to get win or loss. And coming to the time complexity, what will be happening in time complexity, that coming to the chess, each pro will be having a different number of moves in that particular 8 into 8 square, right? So time complexity will be more depending upon the depth of the tree it has, as well as the branching factor content. So let me write the time complexity. Time complexity is nothing but it will be having a time complexity of order of b power m, where b is nothing but the branching factor, and m is nothing but the maximum depth of the tree it has making. So that is what complexity is. So I will also explain how to calculate time complexity, so don't worry. So coming to the space complexity, that is the fourth property of a min-max algorithm. In fourth property, the space complexity will be, space complexity is equal to order of b into m, that is branching factor into the maximum depth. So let us consider, so these are the properties of min-max algorithm. So if branching factor is equal to 3, as well as the maximum depth is equal to 100, so what will be happening to the time complexity? Time complexity will be order of b power m, right? And what is the order of b power m? Order of 3 power 1000. So it is a huge number, right? So the time complexity will be more, and that's coming to the space complexity, what will be happening? So we will be having an order of b into m, that is order of 3 into 100. So we'll be having a space of 300. So these types of drawbacks will be more. For example, if we increase the branching factor to 1000 or 10,000 or 10 lakhs, what will happen? We will be having a huge amount of tree. So in that huge tree, we don't know how to, so it is very difficult to find the optimal solution. So that is one of the drawbacks. So let me take an example how to do the min max algorithm in an example. So this is a starting node a, b, c, d, n, it's n and o. So consider this as a tree. So what I said, min max algorithm is a uses backtracking. So it is uses backtracking, right? So in min max algorithm, it first derives the tree. So from after the derivation of the tree, it will try to it will be try to find the possible route to get the maximum value. So let us try to name them. We will be taking in a randomly. Let us compare when you are going to implement in using a machine learning or using any different trees. So the program itself will be taking the random numbers -1 2. So let me take 2, -3 8 5 2 3 7. So let me take -7. So the first initial step will be given to a maximum percent. The second step will be given to the minimum, and the third step will be given again to the maximum. Okay, so let us try to derive from this. So what is the, let us come from here. So what is the maximum of d node? It is the maximum value node, right? So we have to find the maximum values only from the nodes. So what is the maximum value from for a d node? That is, it has only two branches, that is h and I. So from this h and I, which is the node which has highest value? It is 2. So we have to select the maximum value, that is 2. So for 2 it is d. And coming to the, it has two branches, that is j and k. What is the highest maximum value here? So maximum value is 8. So you can make a note of it here. So coming to the f node, it has two branches, that is m and l. So what is the maximum value here? 5, it is the maximum value. So coming to the g and n, g, it has two branches, that is n and o. So what is the maximum value here? 3 or minus 7? It is 3, right? G will be 3. So next step we have to move to the another percent, that is minimum value. So we have two branches, that is b and c. So coming to the b, so it has two branches, that is t as well as e. So what we have to select only the minimum value. So for selecting the minimum value from 2 and 3, what is the minimum value? It is 2 or 8, it is 2. So minimum value is 2. So coming to the c, it has two branches, that is f and g. So we have to find the minimum value, right? So what is the minimum value in 5 and 3? It is 3. So the second step is also completed. So let us move to the last one, that is, you have to find the maximum value. So what is the maximum value here? 2 or 3? Yes, it is the 3. So we have to find the maximum value 3. So from the above graph, we can simply say that, so it has 3 came from here, and the 3 has been taken from the, and 3 has came from g value. And where does 3 came from? 3 came from the n positions. So this is the path, which will be providing us the win for the maximum portion. So this is the path. Okay, so this is the path. So from a to c to g to n, we'll be having a path. Okay, this is our path where we will be finding the best solution to win in the game. That is what min-max algorithm it is. So let me write the limitations. So what is the limitation from the example? So if there are many nodes, we can't find each what is minimum and what is maximum for each and every node. So that is what it is. So it is slow for complex games, mainly chess, checkers, etc. And what will happen if there are many branches for a particular node? If the branching factor is more, so what we will be having a more time complexity will be increasing, as well as every time space also will be increasing, right? So it has I, if what is the limitation? If it has I huge or I branching factor. So if it has a huge branching factor and it is very slow for the complex game. So that's all about min-max algorithm. So to reduce this limitation, that is to make it fast for the complex games, as well as to make the branching factor for each, we'll be dealing with the alpha beta fueling. So I will be dealing with it in next video, so don't worry. So that's all about in min-max algorithm. So let us see what we have discussed so far. So we have discussed what is min-max algorithm. Min-max algorithm is nothing but we'll be trying to find the optimal sequence of solutions. It is a recursive or it follows recursive and backtrack algorithm. We have seen just in the example, right? So where we will be backtracking to each and every node to get a possible value. So it is playing between the two opponents, that is, one is maximum and one is the minimum. So maximum will try to maximize the value and minimum will try to minimize the value to get the win. So what's the properties? I said four properties, that is, it has completely and it is optimal and it is time consuming, as well as it is space consuming. So these are the properties of min-max algorithm. So then later we have seen the one example where we will be dealing with each and every node for finding the minimum and maximum value, and then later we have find the path where we will be getting a better solution, that is a to c and c to g and g to n. So then later we have discussed the limitations. So that what are the limitations? It is slow for complex games, and if it is having a huge branching factor, so the time complexity will be increased, the space complexity will be increases. So that's all about in this video. I hope you have understood what is min-max algorithm. So let us move to another topic. That's all in this video. Thank you.